Hello everyone, welcome to lesson 4-1. We are finally on chapter 4, representing relationships. We're going to address the questions, how can we model relationships between quantities? And we'll use words such as linear equation. Okay, let's take a look at a real world example and talk about space. To achieve orbit, the space shuttle must travel at a rate of about 5 miles per second. The table shows the total distance, represented by the variable d, that the craft covers in certain periods of time, represented by the variable t. So distance and time, and we are looking at 5 miles per second. That is our unit rate. So let's look at this table. Over here we have time in seconds. 1 second is 5 miles. At this rate, without changing, 2 seconds would be 10 miles, 3 would be 15, 4 would be 20, and 5 would be 25. So clearly we're counting by fives here. Every time there's 1 here, we have 5 here. So write an algebraic expression for the distance in miles for any number of seconds. For any number of seconds. So we understand that we are doing 5 miles per second times t. So I can replace this for any number of seconds. So let's say I'm doing 5 miles in 3 seconds. Okay, this will be 15, correct? Number 2, describe the relationship in words. Okay, well, I just explained it, but a good way to write it out would be, simply put, the distance is 5 times the number of seconds. So every time I have a second, it's going to be times 5, right? Okay, let's graph the ordered pairs. Ordered pairs would be, here we have the time and here we have the distance. Distance is going to be my range, and this will be my domain. So I can graph this as x right here, and this is my y, because 1 second will be 5, 2 seconds will be 10, so this is my range in terms of distance. And you can see, everybody, that this is a proportional relationship, right? Every single time the rule maintains. Well, every time I have 1 here, I have 5 more here. So it's going to be a proportional relationship. Now, graph the ordered pair. We should get a straight line. Let's graph it. So here I have my table, and I've graphed the points. As I mentioned, this column is my x and this column is my y. So at 1 second I have 5 miles. At 2 seconds I have 10. At 3 seconds I have 15, and so on. And it makes a nice straight line, which, as I was mentioning, it's proportional because it'll cut through the 0, 0. So the points appear to be linear. So the graph is linear. The points are linear, meaning it makes a straight line, as you can see right there. Now I forgot to graph these, to label this. We know that this is my time, my distance, and this is my time. So it is important to include that not only this is where we're measuring time, but it's important to include the units. These are seconds, and over here we have our distance in miles. Okay, let's look at one of our key points for this lesson: tables, graphs, and equations. Recall that an equation is a mathematical sentence stating that two quantities are equal, right? Equation, hence the word equation. One side is the same as the other. A linear equation is an equation with a graph that is a straight line. Some equations contain more than one variable. Let's look at our first example, where we are given a table, right? Identifying quarts to liters, right? The table shows the number of liters in quarts. Now remember, when we talk about quarts, we are talking about the standard system from the United States, and liters is the metric system which we use in Canada. So write an equation to find the number of liters in any number of quarts. Describe the relationship in words. In order to be able to describe the relationship, we have to find how they are incrementing. Here we see it's incrementing by a whole unit, by 1, right? But over here, not so much. So the best way to go about it is to actually identify the difference, or how much we've gone up from the first to the second row, and see. So we're finding the difference. So essentially I'm going to take this number and subtract this from it and see how much I've increased. And notice that every single time I'm increasing by decimal 95, decimal 95, decimal 95, and so on, of a liter. Okay, it is a pattern. It is proportional. And you can see here that that's how it's being explained. We want to find the difference, okay, of each one, and we see that from the second row to the first row, right? You take the larger amount and take away the smaller amount from it, and we see that it is 0.95 to 1. That's our unit, okay? And that's how many liters for every quart. Okay, and our equation is going to look like this. Liters is equal to 0.95 quarts. This is what a liter is in quarts. Is, you can say 95% of a quart is a liter, or 0.95 decimal times any number of quarts will give you your number of liters. So now let's look at example 2 and put it into practice. You can see, as I mentioned, let's just about how many liters are in 8 quarts. So if I take 8 quarts, now I can replace my variable of quarts and identify how many liters I have. And you can see that 8 quarts is 7.6 liters. So there are about 7.6 liters in 8 quart. Pretty close numbers there. Okay, let's try this. If you think you understand, again, identify the increments. Okay, here we have our x and our y. How much is it going up by here in this column? And then use the equation to find the cost of 15 buckets. Okay, pause the video and try. Pause now. Okay, I hope you paused the video. Let's address A. Write an equation to find the total cost of any number of tickets. Describe the relationship in words. So we have here number of tickets and the cost per ticket, right? One ticket is $4.50. Will it continue to increase by the same amount for 2 tickets and so on? Well, we have to check. I'm going to take 9 and subtract 4.5 from it. You see, 9 and subtract 4.5, and I'll take the 2 and subtract 1. So that I get now 4.5 or 450 over 1. What does that mean? That's telling us that one ticket is $4.50. It is increasing by that amount. I could check again if I wanted to, but I can see that it's going to continue to, simply by doing math in my head, it's going to continue to increase by $4.50. So now that we know that that's what it's representing, or we can say that our equation now it looks like this. We have $4.50 per ticket, right? Every ticket, that's going to equal our total cost. So total cost is totally based on how many tickets we get, right? And that's our equation. Now they want us to use the equation that we came up with to find the cost of 15 tickets. Let's replace the variable of tickets with that number 15 there, this variable right here of tickets. So now I'll go ahead here to do B, okay? And I will write that equation, C equals 4.5 times T, right? The total cost is 4.5. Now replace, how many tickets is it? It's 15, right? That's what they said. So total number of tickets is 60, well, let's see, 4.5 times 50. I'm trying to do this in my head. I get 67.5. 67, which is therefore $67.50 for 15 tickets. Okay, next example. Example 3. The total distance Marlon ran in 1 week is shown in the graph. Okay, so here's the time in terms of days, right? The first day, the second day, the third day, and so on. And here's your distance in total number of miles, mi. It looks like in the first day, he almost ran 4 miles. It says here, our coordinates are x is 1, and the number of miles, or our y coordinate, is 3.5. To the second day is 7. I know that 3.5 plus 3.5 is 7, so it looks like he's running about 3.5 per day. Another 3.5 here would make it 10.5, and then another 3.5 here would make it 14, and so on. Another 3.5 to 14 would be, so it looks like he's, and you can tell by the straight line, it looks like it is a proportional relationship, and it's increasing on the y, or in terms of miles, it's increasing by 3.5 per day. Right, there we go, we have that. So find the rate of change. Well, the rate of change, and we know this from our previous lesson, we can use the equation to identify the slope. The slope is telling us how it's changing. And to find our slope, we have to take any two sets of ordered pairs and find the difference, where we use slope equals y2 minus y1 over x2 minus x1, right? Rise over run. So we can use any of them. Let's see over here. Let's use 14, nice rounded number over here. 14 and find it over here is 7 and 2. Let's use the nice even numbers, right? Use this one and this one. So my y2 is going to be 14 and my y1 is going to be 7. My x2 is going to be 4 and my x1 is going to be 2, as you can see right there. And I get a slope equals 2 over 7. And if I want to simplify that, it's going to be 3.5 over 1, or just simply 3.5 miles per day. All right. Step 2. This looks like something we've already done. Slope-intercept, right? Y equals mx plus b. Okay, to find the y-intercept, use the slope of the coordinates of a point to write the equation on the line in the slope-intercept form. I know most of you already know the formula, y equals mx plus b, so that's our slope-intercept form. Let's replace our slope as we've already identified, 3.5x, right? And then for x, for example, over here, we can replace it on, let's say, day 2. Okay, day 2, we know we ran 7 miles, right? Or he ran 7 miles. So we just take one set of points. Use the point 2 and 7, right? And then when we do that, we solve, right? 3.5 times 2 equals 7, and then we bring it over to the other side, or equals positive 7. We bring it over to the other side and subtract it from the 7. It's going to give us 0. So our y-intercept is 0, which means it's a proportional relationship. It's going to go right through 0, 0, right? So our y-intercept starts at 0 when we graph it. And we know that when we see the graph right here, if I were to draw a straight line, we can see that our line will go through the origin of 0, 0, which makes this linear equation proportional. Now that we know that our b in the equation y equals mx plus b is 0, we don't actually have to include it. And we know that our slope is 3.5. So I'm still using that equation here to solve for anything. Now that I have that formula, that equation, I can solve for any number of miles. So here we have y equals 3.5 times x. Let's say it's 14 miles. I multiplied, and I get my y. Remember, my y is the distance. Okay? So Marlon will run 49 miles in 2 weeks. 2 weeks is 14 days, right? 14 days. Each day is 3.5. Okay, let's try this example. If you think you can do it on your own, please pause the video now, try it, and then watch how I do it. Pause now. I hope you paused the video. Now let's take a look at the graph. This is the number of trees saved by recycling paper, okay? And we have, on our y-axis, we have the total trees saved, and along our x-axis, our domain is amount of paper recycled. In tons is our unit, okay? And this is number of trees. And we see if we save 1 ton, we're going to save 17 trees. 2 tons, 34 trees. 3 tons, 51. Well, if we see 17 times 2 is 34. And then 17 times 3 is 51. And then 17 times 4 is 68, sorry. So it does follow a straight line, you see that? So it's a linear relationship. And we can see that it's going to go right through 0, 0, so it's proportional. Now let's see. Write an equation to find the total number of trees and y that can be saved for any number of tons of paper. So again, we can take just 2 sets of coordinates, right, and find the difference between the 2 coordinates to identify the slope. We could use our equation m equals y2 minus y1 over x2 minus x1 and use any sets of coordinates. I could use these ones or these ones and so on. I'll use the first two. So now I'm going to replace my variable, this be my y2, my y1, my x2, and my x1. I'm going to replace them right here. So now I have 34 minus 17, and we know that's 17, and below we have 1. So our slope is simply 17 over 1, right? Now, we have to come up with an equation where we're going to say that our total number of trees, right? I'm still answering question C, by the way. Our total number of trees is equal to our slope, or our change, rate of change, okay, times the number of paper, okay, as you see here. I'm using P for paper. So if I replace my variables, I'm going to have my total is trees, and I know that my slope is 17. It's 17 per ton, right, times P, times tons per paper. So there we have, that is answering C, because it's asking us to write an equation. Now to answer D, we have to use our equation. So the total number of trees times the slope or rate of change, which is 17, times the tons of paper, right? It's 17 per ton, right? Now use the equation to find how many trees could be saved if 500 tons of paper are recycled. So this is a 1 ton up to 5 tons. We need 500 tons. What I could do is just simply multiply it by 5 and then add 2 zeros, right? That would become 500. I could do it like that, where I do T equals 17 times 5, or 500. I'll do times 5 because it's a lot simpler. And that would give me 85, 85. And then if I get my 2 zeros in there, sorry, it's kind of hard to be, I can't write on the pink. It's going to be T equals 85. Now it's not just 85, because I did times 5, not 500. But if this number were 500, I would have to include the 2 zeros missing in the 500 here. I would have to include it in my product. So it would be 8,500. So therefore, 8,500 trees would be saved. Okay, I hope that made sense. Let's continue by looking at our key concept. Okay, multiple representations of linear equations, which means what is the linear equation telling us? Okay, in words, distance traveled is equal to 12 miles per second times the number of seconds. So if it's 12 miles per second, if continue at the same rate, 2 seconds will be 24 miles, and so on. In an equation, it's written as the distance is equals to 12 miles per second. So whatever number of seconds, you'll multiply it times the miles, and you'll have your distance, okay? As a table, we have our seconds and our distance, our miles. This will be our domain, and this will be our range, x and y, right? And then finally our graph, where we actually do plot it out, and we have our order pairs. And these order pairs, you can see, create a linear, or have a linear relationship that is proportional, because if I draw a line, it will go through 0, 0. So words, equations, tables, and graphs can be used to represent linear relationships. Example 5. Chloe competes in jump rope competitions. Her average rate is 225 jumps per minute. So that's our unit, right? So if she continues at this rate, 2 minutes will be double this number of jumps, which would be 450, right? If you double this. So write an equation to find the number of jumps in any number of minutes. In any number of minutes, it would have to mean that if this is our rate of change, this is our slope, 221 over 1, right? 225 over 1 is our slope. In minutes, it would have to be multiplied by the number of minutes. So let J represent the number of jumps, the total number of jumps, and M represent the minutes. Okay, so you see 225 jumps per minute, every minute, and you multiply those, that'll give you a total number of jumps. That's pretty straightforward. Number 6, make a table to find the number of jumps in 1, 2, 3, or 4, 5 minutes. So we make the table. We have our number of minutes, our number of jumps, okay, 225 jumps per minute, 225 jumps per minute. The rate doesn't change. And then when we multiply them, okay, we get our J, our total number of jumps. Okay, And then we can graph it. And you can see the linear equation with the unit rate at 225 per minute. And you can see it here, just slightly over the 225 per minute. All right, if you think you got it, let's do this one right here. Financial literacy. Please pause the video and try it on your own. Pause now. Paul earns $25 for grooming a dog plus $18.50 per day for boarding the same dog. Okay, so it sounds like we have a y-intercept, right? It's $25. Sorry, $25 is just the starting fee, right? For grooming plus $18.50 per day. $18.50 it's gonna have to get multiplied by the number of days, and these two values will get added. So it'll be essentially 25 plus $18.50 times D, right? Times the number of days. You'll see what I mean in a minute. Write an equation to find the amount of money Paul earned, M, money, for grooming a dog once and boarding it for any number of days. Okay, so the way I'm looking at this is right here in this graph, I'm going to write my number of days right here, right? I know that it's going to be 25 plus 1850, okay, times M, times the number of days. That's what it's going to equal. So if I have, let's say, 5 days, yeah, that's 5, because it's telling us here in the next question, make a table to find his earnings for 5, 6, 7, or 8 days. So let's start with 5 days. Here's 5 days, 6 days, 7 days, and 8 days, as we were told to do here, right? And then if that's the case, then I'm going to write 25 plus 18.5, $18.50 times 5 days, right? So it's $18.50 per day, so times 5, and then I add the 25 at the end. If you're thinking of slow intercept, this would be our mx, and this would be our plus b, right? So we actually start at 25. And our m, which is the total amount of money, when solving that, this would be 117.50, or 0.5. 6 days, same thing, guys. 25 plus 1850 times 6. So I multiply first 18, order of operation, $18.50 times 6 days, plus the original 25 is going to cost, or I'm going to make $136, right? Same thing for 7 days, $25, because the $25 is just for grooming the dog. So we groom the dog, make 25 bucks. And then we keep the dog per day for $18.50, and this is 7 days. So we have to multiply that times 7, 1850 times 7 plus 25, going to equal 154.50. And finally for 8 days, 25 bucks for grooming the dog plus $18.50 per day, and it's 8 days times 8 days, going to equal $173 even. Okay, now we got to graph this. If I'm looking here at my graph, I'm going to zoom in a little bit just to make sure I know. We said that for 5 days, okay, which is down here along the days, right? For 5 days, I should label this days, right? And over here is total earnings in dollars, right? Sorry for the mess. I'm just trying to do it somewhat quickly. So we have 5 days, okay? And in those 5 days, I made almost $120. So just slightly under that. It would be at around 117, so it would just be just under that, okay? And then 6 days, just under 140, right? 136. 6 days, just under 140, right there. Okay, 7 days would be between 150 and 160, because it says right here, as you can see, 154. So it would be just between 150 and 160, right about here or so, right? So I'm going to go ahead and do that right there. And then finally, 8 days, I have just over 170. As you can see here, 8 days, 173. So I go up to 170, just over it, right about there will be a good place to put it for 8 days. And you can see that my relationship is linear, right? It's not proportional. It's definitely not proportional because I start with $25 just for grooming the dog. I could just groom the dog and only keep it from 1 day, but I have a y-intercept of 25. Notice that our numbers did not start until after 100, and then they get kind of clustered between 115 and 180. So because we have no data for the first 110 numbers, we do this little symbol here to explain that the information has been kind of crushed in here, and really the data starts after 110. That's why we do this. Okay, friends, I hope that made sense to you. Please take a look at the guided practice. We will start class with this. Make sure you feel comfortable with it and that you are able to do question 1 or question 2. And if you don't, please take a look at the examples. Go back in the video and take a look and make sure that if you still don't know how to do it, you come to class with questions. All right, everyone. See you in class.